Okay, now let's take a look at these sets down here and figure out what all of these are based on the definitions here. First, the power set of D. D has 2 elements, and so the power set will have 2 to the 2 or 4 elements. So this is equal to empty set. Excuse me. The set containing 10, the set containing 20, and the set containing 10 and 20. So that's the power set for D. A union D. Okay, A union D would be 7, 8, 9, 10, 11, 10, 20. Now, to avoid making it look like it has 7 elements, I'm not going to list the 10 twice. So 7, 8, 9, 10, 11. I've already listed 10 once, and so I don't list it a second time, 20. Now, there would be nothing quote-unquote wrong with listing out 10 twice. It would be the same set, but it certainly looks better to not repeat elements. A intersect D. A intersect D is the set of everything that's in both A and D. And as we just saw, 10 is common to both, and that's it. And so A intersect D is the set containing 10. Notice it's not the number 10, it's the set that contains 10. All right, A cross D, A times D, the Cartesian product of A and D. All right, this is going to have 10 ordered pairs. So A has 5 elements, D has 2 elements, and so this will have 5 ordered pairs. So this means the first part comes from A, and the second part comes from D. So 7, 10, 8, 10, 9, 10, 10, 10, and 11, 10. So that's the first 5 ordered pairs. Then the next ordered pairs with 20 as the second value. 720, 820, 920, 1020, and 1120. And so this set of 10 ordered pairs would be the Cartesian product A cross D. D cross A, well, it's going to look an awful lot like this, except that the roles will be reversed. The first number comes from D, and the second number comes from A. So 10, 7, 27, that's the first 2. Then 10, 8, 28. 10, 9, 29. 10, 10, 20, 10. And then finally 10, 11, 20, 11. And so that would be the Cartesian product D cross A. It would have been perfectly acceptable just to flip these 10, 7, 10, 8, 10, 9, 10, 10, 10, 11, and I would produce the exact same list that's written out here, just in a different order, and as we've already established, the order does not matter. Okay, number 6. A intersect B union D. So this says figure out A intersect B first. A intersect B, 9 is common to both lists, and that's it. So 9 union D, 10, 20. And so that's going to be just simply 9, 10, and 20, this set with 3 elements. Okay, this one says A union D intersect B union D. Okay, so A union D, we just did it here, 7, 8, 9, 10, 11, 20. Intersect. Then B union D, if I take the union of B and D, I see that nothing is common to B and D, so I can just simply list out all 7 things. 3, 6, 9, 10, 12, 15, and 20. And they don't have to be listed in order, but certainly makes it easier to read if they're listed in order. Now I take the intersection of this set and this set. So let's see, what's common? 9 is common to both, 10 is common to both, and 20 is common to both. So this is 9, 10, and 20. And this is actually one of the theorems from class. Not surprisingly, these 2 things are the same. And it turns out that, in general, union distributes over intersection. And so A intersect B, whole thing union D is equal to what you see here on line 7. Okay, B minus C. So this means everything that's in B but not in C. So what's in B but not in C? Well, 3 is in C, so I don't want to list that. but all these other things are not in C. So 6, 9, 12, 15. Those are the things that are in B, but not in C. C minus B. What's in here that's in B? Well, 3, and that's it. So C minus B would be equal to 2, 5, 7, 11, 13, 17, 19, and that's it. So this is the list of things that are in C but not in B. Okay, number 10. If the universal set is all the integers, positive integers 1 through 20, find A complement intersect B complement intersect C complement intersect D complement. Okay, so this one's going to take a little bit of work, so let me do it down here. Okay, so A complement. And let me write down what the original set was. 7, 8, 9, 10, 11 complement. The universal set are all the integers from 1 to 20, and so I would write this out as 1, 2, 3, 4, 5, 6, and then 8, 9, 10, 11, or sorry, 8, 9, I'm sorry, I blew it. 7, 8, 9, and 10, and 11 aren't in, so 12, 13, 14, 15, 16, 17, 18, 19, and 20. All the numbers from 1 to 20 except for 7, 8, 9, 10, and 11. B complement. Now B was 3, 6, 9, 12, and 15. So I want the complement of this. And so that's equal to 1, 2, not 3, 4, 5, but not 6, 7, 8, but not 9, 10, 11, but not 12, 13, 14, but not 15, and then everything else up until 20. C complement. Now C were all the prime numbers up to 20. And so the complement will be 1 and then all the composite numbers. 4, 6, then everything between 7 and 11, so 8, 9, 10, 12, then between 13 and 17 we have 14, 15, 16, and then 18 and 20. And then finally D complement. D was only 10 and 20. And so that'll be everything except for 10 and 20. So that'll take me a while to write this out, but everything except for 10 and 20. That's between 1 and 20. Okay, so those are the 5 sets. Now, the question asks for A complement, intersect B complement, intersect C complement, intersect D complement. So let's go through these and see what's in all sets. 1 is in all the sets. 2 is not in C, so I don't list that. 3 is not in C, so I don't list that. 4 is in all the sets. Five is not in C complement. 6 is not in B complement. 7 through 11 I don't have to worry about. 12 is not in B complement. 13 is not in C complement. 14 is common to all 4. 15 is not in B complement. 16 looks like it's in all 4. 17 is not in C complement. 18 is common to all 4. 19 is not in C complement. And 20 is not in D complement. Shouldn't list that. And so the intersection has these 5 elements. Okay, now number 11, find this. So let's figure out A union B union C union D complement. Alright, so here are the numbers. So let's see. 2's in there, 3's in at least one of them, 4's not anywhere, 5 is in at least one of them, 6 is in at least one of them, 7 through 11 are in at least one of them, 12 is in at least one of them, 13 isn't at least 1. 14 is not to be found. 15 isn't at least 1. 16 is not to be found. 17 is here. 18 is not to be found. 19 is there. And 20 is there. And I want the complement of this. So everything from 1 to 20 that isn't there. So 1's not there. 3, 4's not there. 6, 7, 8, 9, 10, 11, 12, 13, 14's not there. 16 is not there. And 18 is not there. And not surprisingly, these two things are the same by De Morgan's laws. So that was a brute force way of confirming De Morgan's law that these two things are in fact always equal to each other. And just this problem illustrated that.